postulates. Everybody say postulates.
Postulates.
Okay. What we're going to do with this, because there's nothing for you to really write on either of these pages, is I just need like your full undivided listening attention, okay? Because we're going to read through these and you're going to try in your head to understand what is this sentence saying and why might it be important, okay? So, can I get a volunteer to read what postulate 1 says? Alex, take us away.
Through any 2 points, there is exactly 1 line.
Perfect. Through any 2 points, there is exactly 1 line. Give me a thumbs up if you agree with that. Ava agrees. Melanie agrees. Abigail, Arisha agrees. Okay, that's just the definition of a line, right? Postulate 2. Can I get a volunteer to read postulate 2? Yeah, Aldrich, thank you.
Through any 3 non-collinear points, there's exactly 1 line.
Perfect. And this is what we talked about in a previous unit too. Through any 3 non-collinear points, so 3 points not on the same line, think of a triangle, the points, there's exactly 1 plane. That's like a flat surface. Right? Give me a thumbs up if that sounds okay. That second one. Okay. A lot of this stuff is going to sound super simple, but it's, important adjacent, I would say. Postulate 3. Can I get a volunteer to read postulate 3? Aaron, go for it.
A line contains at least 2 points.
Beautiful. Give me a thumbs up if you agree with that. Yeah, it's basically the same thing as postulate 1, right? Almost like we don't need postulate 3. But whatever. Postulate 4. Can I get a volunteer to read postulate 4 for us? Wait, did I read what a postulate... Oh, sorry. We didn't read what postulates are.
Oh.
Postulates are statements that can be accepted as true without proof, which is why these all seem so obvious. So these are basically reasons that we're going to use when we see what a proof looks like. So these are basically just like givens. These are things that we should already know. Like postulate 4, basically the same as 2. A plane contains at least 3 non-collinear points. Okay? Can I get a volunteer to read postulate 5 for us? Christian?
If 2 lines intersect, then their intersection is exactly 1 point.
Exactly. If 2 lines intersect, right, then their intersection is that 1 point in the middle. Great job. Postulate 6. Tia, go for it.
If two planes intersect, then their intersection is a line.
Exactly. That was the demonstration I did with the paper where I cut a hole in it and put the paper through it. You guys remember that?
Oh, yeah.
Yeah, so 2 planes intersecting, that line is the intersection point there. So these are all like just obvious things that we know, but if we're going to use them as a reason, we need to know what they are. Okay, now let's get into some different stuff. The segment addition postulate. Can I get a volunteer to read that? Chloe, thank you.
If C is between B and D, then BC plus CD equals BD.
Okay. How are we feeling about that one? Thumbs up, down, sideways? It sounds kind of ugly, right? It always helps us out if we draw it, right? So it says, if C is between B and D, C is between B and D. Does that look like it matches up with that first statement?
Yeah.
Yeah? Then BC, I'll call it X, plus CD, I'll call that Y, equals BD. X plus Y. Does that sound right to you?
Yeah.
Yeah, pretty straightforward, right? When you read it, you're like, I don't even know what that's talking about. But if we draw out a diagram, which is really going to help us with this, makes a little bit more sense. Okay? That was Chloe that read that, right? Okay, thank you. Can I get a volunteer to read angle addition postulate? Yeah, Liana?
If D is a point on the interior of angle ABC, then M
Measure of angle.
Then M measure of angle ABD plus M measure of angle DBC equals M measure of ABC.
Perfect. Yeah, and the M means measure, right? So measure of angle ABD plus measure of angle DBC. There's another one. We're like, I don't even know what's happening. So let's see. D is a point on the interior of ABC. Let's see if we can visualize this one. So I've got some angle ABC, C, A, B. Okay, where is D at?
Inside.
Somewhere in here, right? That means that ABD, I'll call that X, plus DBC, I'll call that one Y. If I add those together, that gives me ABC, which is this whole thing. right? Give me a thumbs up if that makes sense, that first one, or that second one. It's the same thing as the line segment, just in angle form, right? It's basically saying if I have some angle measure in the middle, then the two parts make the whole. If I have some point in the middle, not necessarily directly in the middle, but some point in between, then the two little parts add together and equal the whole. Self-explanatory, but we're going to need it. Thank you, Liana. What about linear pair postulate, our last postulate here? Davis, thank you, sir.
If two angles form a linear pair, then they are supplementary.
Perfect. This one's going to help us out a lot. Even though, again, it seems very, very straightforward. Tyler.
What is the equal sign?
Yes. This is an equal sign with a little squiggly on top. Have you guys ever seen that before?
I think so.
Okay. All it means is congruent.
Oh.
Yeah. There's really, honestly, like, I mean, you guys know I try and keep it as simple as possible. There's really no difference between a congruency sign and an equal sign. You may have a teacher that argues that they're different and they're used in different contexts. I don't think so. If I put an equal sign in here, it wouldn't change what we're saying about it, so it doesn't really matter. Linear pair postulate, we said if two angles form a linear pair, then they are supplementary. What's a linear pair? Did we just learn that maybe last week or something?
We might have.
I think so.
Alex, you remember what a linear pair is?
It's like two angles that connect to each other that make like 180 degrees or like a straight line.
Exactly. A linear pair looks like this. A line of two adjacent angles. Right? Adjacent angles, what do they have in common? Think about mine and Miss Karan's classroom. What do we have in common? The wall in between, right? Here's the wall in between. So linear pair is two adjacent angles where the base of those adjacent angles is a straight line. Well, obviously those are supplementary angles because they make a 180 degree flat bottom, right? That makes sense, kind of? Okay. So that's our first little section here is postulates. Any questions I can answer about any of those postulates? How are we doing so far? Up, down, sideways? Oh, I forgot to mention, this is going to be super boring too. Sorry. I know. We'll get through it. Next one is definitions. We hopefully should all know what a definition is. Definitions establish the precise meaning of a mathematical term or a concept. We can use these as reasons in a proof, just like our postulate. So, first one, definition of congruence. Can I get a volunteer to read that out for us? Colby.
If AB equals CD, then segment AB is congruent to CD. If measure of A is congruent to measure of B, then measure of A is congruent to B.
That's right. So this is one of those things where like it really doesn't matter because the equal sign of the congruency sign, it's not really any different. So this says that if AB equals CD, right, when we're talking, this is technically the difference. When I'm saying AB equals CD, I'm talking about the number that it represents. So if I had A, B, and CD, and they're both 4 units long, right? I would say that AB is equal to CD. I'm talking about the measure. But when I say AB is congruent to CD, I'm not talking about the number, I'm talking about the shape. Which is why it doesn't really have a difference because the shape is the number. So I don't know. The same thing down here. Angle A is congruent to angle B, then the measure of angle A is congruent to the measure of angle B. Which means if I have two angles that look exactly the same and are exactly the same, then whatever degrees one of them is, the other one is. Very straightforward. Yeah. Like it's saying that if I have two angles that are both 90 degrees, right? If I have two right angles, the angles are congruent, then their measures, 90 and 90, are also congruent. But again, obviously, okay? I'm not going to over-explain that one. We'll see where we're going to use it in a second. Definition of midpoint. Can someone help me with that one? Yeah, Anthony?
If P is the midpoint of segment AB, then AT equals PB.
Perfect. And that's kind of like what we talked about here. Basically, if C is directly in the middle here, then BC is equal to CD. We talked about that with midpoints. We're not going to go too deep into it. Thank you, Anthony. Definition of a straight angle. If angle A is a straight angle, then the measure of angle A is 180. Right? So this is what I was talking about. If angle A is a straight angle, I'm talking about the shape of it, then the measure of angle is 180. I'm talking about the actual number of degrees that it is. Definition of a right angle, same thing. If angle A is a right angle, then the measure of angle A is 90 degrees. We all know what a right angle is. We don't really need a explanation, but there it is. Can I get someone to define a linear pair for us? Yeah, Tristan.
If two adjacent angles form a straight line, they are a linear pair.
Perfect. So this kind of goes along with what we talked about with the linear pair postulate, right? If two adjacent angles form a straight line, they are a linear pair, which then leads into if two angles form a linear pair, then they are supplementary. So therefore, if two adjacent angles form a straight line, they are supplementary. And we'll talk about what that is in a second. Definition of complementary angles. Thank you, Tristan. Can I get someone to read that one? Last two on this page. Alex, go for it.
If angle Z and angle Y are complementary, the measurement of angle Z plus the measurement of angle Y is equal to 90.
Exactly. And that's, 90 or 90 degrees. Doesn't really matter. Give me a thumbs up if you agree with that one. Two angles are complementary. They add to 90. Yep, we know that. And definition of supplementary, same thing. If S and T are supplementary, then the measure of S plus the measure of T is 180. Everyone cool on that? Okay. So again, definitions, these are things we've already talked about, things we've already defined. We're just putting it into a kind of standard form, like that. Now let's go to properties. Okay, on the second page, we all have the second page glued in, right? Okay. Properties are fundamental characteristics or rules that define how numbers, shapes, or mathematical concepts behave. So you'll notice there's a lot less words in properties. These are more so just kind of examples of what these ideas are. The addition property. If A is equal to B, then A plus C equals B plus C. All I'm doing is if I add C to one side and the other, it doesn't change anything about my equation. We already know this from our equations unit at the beginning of the year. Whatever I do to one side, I have to do to the other. So this property just tells me that if I'm adding the same thing on both sides, I'm not really changing either side. I'm making it a little bit bigger, but I'm not changing what they are. Same thing with the subtraction property. If A equals B, then A minus C equals B minus C. And I'm highlighting the C's here. Multiplication property. If A equals B, then A times C equals B times C. These are all just our inverse operations. That's where we've seen them before. Now the division property one is a little bit different. Can I get a volunteer to read the division property for me? Tyler, go ahead.
If A is equal to B and C is not equal to 0, then A over C equals B over C.
Exactly. So it follows the same structure as the other three properties, but what's different about this one? What other information did we get in that property? Alex?
C is not equal to 0.
Why can't C be 0? What do you think? Alex, why can't C be 0?
Because you can't divide by 0.
Exactly. You can't divide by 0. So if I'm dividing both sides by 0, that's going to mess everything up. I can't do it. So the only stipulation on division property is that C can't be 0. Basically saying you can't divide both sides of an equation by 0. Then we have the distributive property. Everybody knows the distributive property. We know it very well. A times the quantity B plus C. I distribute it to the B and the C, giving me AB plus AC. We know that one already. This one is my favorite right here. Can I get a volunteer to read out the reflexive property for me? Yeah, Tia?
Angle 1 is equal to angle 1.
That's right. Angle 1 is congruent to angle 1. Why do we have that? I think it's actually going to come up, ironically enough. Maybe not.
Something can't equal something else.
Yeah, it could be why. Maybe. I don't know. I think so. That sounds right. Alex?
It's pretty much used for
Yeah. Yeah, like a lot of this stuff, but that's okay. Symmetric property, if A plus B equals C, then C equals A plus B. This one also seems fairly useless because we know that equal signs go both ways. But this is the reason why proofs are so annoying, because it takes things that we've already accepted as truth and tries to explain them, right? I know that if I flip the sides of an equal sign, it's not changing anything. But the reason I know that is because of technically the symmetric, right?
Yeah.
Okay, it sounded weird when I first said it. Symmetric property, right? We don't learn the symmetric property, but it's something that we've kind of innately just gathered through our work. And that's what a lot of this stuff really is, right? When we go through equations and I tell you, what am I going to do to both sides? And you say, oh, I'm going to add 3 to both sides. You don't say, I'm going to do the addition property and add 3 to both sides, right? We cut that kind of part out, but we're doing the exact same thing. Transitive property. This one is actually my favorite. I was lying about the reflexive property. Can I get a volunteer to read the transitive property for us? Yeah, go ahead, Changzi.
If A is equal to B and B is equal to C, then A is equal to C.
Aha! If A is equal to B and B is equal to C, then A is equal to C. Okay, this is actually a really prevalent, like, logical reasoning, or deductive reasoning, a good way of putting it, that you could use, like, not even just in math, but in life, right? If, let's say, you guys think of a good transitive property in real life, Liana?
If Johnny is 6 feet tall, and Timmy is 6 feet tall, and Tommy and Jacob is 6 feet tall, and Tommy's the same. What are the names? I forgot their names.
I don't know. We got a little away from that one. You were on the right track, but that would have led to Tommy is Jimmy, which, no, they're just the same height. Anthony?
Let's say A is Patricia, B is Timothy,
Okay.
and then C is Justin.
Okay.
Let's say Patricia is 6'7",
Okay. Why is everyone going to height? Why is that the immediate example?
and then Timothy is 6 feet, and then Justin is also 6 feet. So if we're after that.
Okay, sorry, got a little away from us there too. Let me give you. Did I not give you guys an example earlier in the year? Maybe that was Math 8. The LeBron James example? No? Okay. NBA players are rich, right?
Yes.
LeBron James is in the NBA, right? Therefore, LeBron James is rich. That's the transitive property. Okay, we don't have to talk about height. That gets a little bit messy. Tyler, did you have one that doesn't have to do with height?
I think so. It was like you have like never mind.
Okay. There's tons of different examples. That's just the first one that I always think of. If everyone is failing Math 1, okay?
Yeah, you can pick one person.
Wait, everyone that's in Math 1 is failing. I am in Math 1, therefore I am failing. That's the transitive property, right? It's like we're taking two statements and we're connecting them like a Venn diagram with what's similar in the middle. That's kind of a good way to think about it. Does that make sense?
Yes.
No, it doesn't make sense?
Yeah, I get it.
I'm going to give your group
I can think of
2 minutes to come up with an example of the transitive property. And the best example is going to get candy. 2 minutes. Figure it out. You'll do it. You'll figure it out.
I have here, you have here, you have.
Okay, let's actually think. You know what? Does that make sense or not? I think so. I got it. I remember so Tommy is 16. Tommy and Jimmy have like Everyone at the table has to come on.
Okay.
Wait, 8 your word. What is that? No,
All right.
I'm sorry.
Did you guys come up with something for the transitive property?
Yes.
Okay, I'm interested to hear. As long as it is appropriate. You guys you heard what I said, right? But it's something different? Okay. We're going to start back there with Aaron. What did you guys come up with, Aaron?
Alright. Judah came up with if legs can walk and you have legs, you can walk.
Give him a round of applause. That works. I don't know if it's the legs that can walk. Maybe you can walk. But I like it. That was great. Very good job. I like it. Who else we got? Alex, you got yours? Okay. We'll come back to you. Anthony,
I know.
you got it?
Yeah.
Okay.
If all my family members have 10 fingers and I am in the family, that means I have 10 fingers.
Exactly right. Give Alex a round of applause. That was great. Good job, your group. That works for sure. Anthony? This doesn't involve hatred, right? Okay, good.
If I'm friends with Melanie, and then Melanie is friends with Creed, then that means like I'm friends with you.
Exactly. That's right. Well, you would think, right? That's where the phrase, like, any friend of Mr. Church is a friend of mine. That's where that phrase comes from. It's basically the transitive property. So, yeah, absolutely. If you get along with Melanie and Gurpreet gets along with Melanie, chances are you're going to get along with Gurpreet. Right? That's the transitive property. Any other examples? I think you said you have one up here? No? All right. Tyler, your group already went. Ava?
Okay, if I had a twin and I am 14, then my twin is also 14.
Okay, good. So, Ava has a twin. The twin is 14. Therefore, Ava is 14?
Yeah.
Yeah, that works. Give Ava a round of applause. That works. Any other examples? Are you sure? Go ahead. Okay. Tyler, last one.
If my immediate family is dead and I'm into the family, I'm also dead.
That's not.
No, I don't think that one will work. I don't think that. I would say I like your thinking, but I appreciate your thinking. I don't think that one will work. Arisha, did you have one? Chloe does. Uh-oh. Do you guys not have one? That's okay if you don't. Was it the one that you told me?
No, it's the one she told you.
Yeah. Okay, that's fine. Yeah, that definitely works. That one was good. I like that one. All right. So that's the transitive property. Everyone got a good understanding of that now? That was a good 5-6 minutes. Substitution property. Now this one is all words. Can I get a volunteer to read out substitution property if it's not super blurry? Ava, go for it.
If one quantity is equal to another, then the first quantity can be substituted for the second in any expression or equation, and the expression or equation would still be true.
Exactly. This kind of goes along with the transitive property, right? If I say that, I'm going to write this in here. If I say x is equal to 2 in one equation, and then I have 2x equals 8 in another equation, what can I do with this 2? I can plug it into the other equation. It's a substitution property.
You just substitute it.
Yeah, we do this all the time. Oh, well, okay.
Well, the problem was not.
Turn it into 4. I didn't think about it like that. You're right. We could say that x is not a solution to 2x equals 8, but sure, change it to 4. That makes more sense. Good catch. Okay. But that's what the substitution property says. It says that if x equals 2, and then I have this expression, I can plug 2 in for x. That's all it means. But again, we know how to do that already. Okay? Last but not least, that was our properties. Theorems. Theorems are true statements that can be proven through the use of postulates, definitions, and properties. So everything that we've talked about are all my like reasonings for proving something like these theorems. Can I get a Pythagorean theorem is definitely a theorem that we could prove using postulates, definitions, and properties. Alex, can you read a complement theorem for me?
If two angles are both complementary to the same angle, then the angles are congruent.
Exactly. If two angles are both complementary to the same angle, then the angles are congruent. We can prove that using all the stuff that we talked about. Supplement theorem is the same thing. If two angles are supplementary to the same angle, then the angles are congruent. And we saw this a lot with our parallel lines, right? All of my acute angles are supplementary to all my obtuse angles. Therefore, all my acute angles are congruent, right? And then the vertical angles theorem, last one here. Anyone has one? Tristan, go ahead.
If two angles are vertical angles, then they are congruent.
Exactly. That one's nice and easy. That's almost like a definition, really. If two angles are vertical angles like this, they are congruent. Tyler.
Can you explain the complement theorem?
Yeah. So the complement theorem says that if two angles are both complementary to the same angle. So what would that look like? That would look like, I'll do it down here. If I have let's call this ABC, and it's 25 degrees, right? And I have this angle over here, that's DEF. Okay, and then I have GHI. Okay, so if I have these three angles, right? The complement theorem says, let's say I'm given the fact that ABC is complementary to GHI, right? DEF is also complementary to GHI. Therefore, DEF is equal to ABC. It's basically just the transitive property again. Which is why I said it's so important, because you see it a lot. Right? And exactly like your guys' example over there. If Anthony's personality complements Melanie's personality, and separately Gurpreet's personality complements Melanie's personality as well, there's a good chance that Gurpreet and Anthony's personalities will complement each other. That's what, that's what the complement theorem is saying. Same thing with supplementary, but 180. Okay? How are we feeling? Good?
Good.
It's not too bad. I mean, it's a lot of information at once, but it's all stuff that we already know, right? Okay. It's nothing too crazy, I would hope.
It's a lot of reading.
It's a lot of reading, I know. I appreciate those of you who read. I'll get you some candy before we get out of here. Let's get our last 2 pages. Well, our 3rd page.
Oh, yeah.
Can I get some candy? Can I get some candy?
I don't think you read.
Put your forehead up.
Me and my mom are okay, so bro,
What was your example?
my dog is not related to me.
Why do you want to make a pen like this?
Because
Stop sagging.
good job. That's really good. Makes perfect sense. You need 3 statements, right? We are in the class, the whole class is sick, therefore we are sick. Exactly. Good job.
What are you doing?
Sit normal. Can't have anything.
It's gone. If I'm in a level, then I am gone.
Yeah.
Oh yeah.
Wait, why are you afraid to say that again?
Excuse me.
Because not good.
Because what?
It's not good like everything else.
That one was really good. I don't know what you're talking about. You gotta have more confidence.
We're at least trying
I don't wanna do this.
All right, everybody got that glued in?
No.
No.
About to.
You're about to, okay.
No. I'm ready.
I'm ready.
Hmm? I already said a bunch of times how many pages it is.
Like from
All right. So this is now the process of writing a proof. We've got all the backstory. We've got an arsenal full of postulates and definitions and properties that we can use to answer these types of questions. So here's kind of what it's going to look like. We're going to list out the given information. We're going to be given a certain amount of information at the beginning. How many of you have played Sudoku before? Right? Does it start out with every box blank? No, because that would be either the easiest Sudoku ever or the hardest Sudoku ever, depending on, I guess, it'd probably be pretty easy. But you need some information in there, right? Proofs are the same way. I can't just come up with something out of nowhere. I have to know what information I'm given, and then what information I'm trying to prove. What our job is going to be to do is fill in all the gaps in between. Sometimes it's just a couple, sometimes it's a lot. We're going to start off nice and simple. What we're doing is creating a deductive argument that links the given information to the statement we are proving. Like I said, we're filling in all the gaps. We're going to justify each statement with a reason. That's why it's called a proof, right? If you say, I know you're cheating on me, you probably need some proof to back that statement up if you want it to work, right? That's why we have our postulates, theorems, properties, and definitions, right? Then we're just going to restate what it is that we've proven. If you're writing an essay in English, what's the last paragraph of your essay typically going to be? In conclusion, everything I said. Boom, right? Same thing with a proof. So when I said it's going to be like we're writing paragraphs, we're going to be writing essays, not literally, but the structure is very similar, right? My introduction is what I'm given. What information am I given in this first one?
Angle 1 is equal to.
Angle 1 is congruent to angle 2. Angle 1 is congruent to angle 2. Right? We know that for a fact. That is technically the only thing that we know in terms of numbers. Angle 1 is congruent to angle 2. Well, we know a lot more, but we have to figure out what we know first. What are we being asked to prove? That angle 3 is congruent to angle 4. Now, hopefully all of us will look at this image and go, well, obviously angle 3 is congruent to angle 4. Give me a thumbs up if you see that angle 3 is congruent to angle 4. Right? Who can explain to me why is angle 3 congruent to angle 4? This is going to help us. Actually, you know what? You guys are going to do it together. Take another 2 minutes in your group. Actually, 1 minute. And explain just in the most basic terms. Don't use the postulates. Don't use the theorems. Nothing like that. Just explain to each other, how do I know that 3 and 4 are congruent? Because I guarantee you some of the things you come up with are going to be some of the things that we list. All right? Go ahead. All right. Any ideas? What'd you guys come up with? I know Aldrich and Andrew came up with something great. You guys want to share it or no? 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 Okay. Changzi, what'd you guys come up with?
They're both vertical.
What do you mean?
3 and 4 are vertical, and 1 and 3 are vertical, which means they are all.
3 and 4 vertical.
So 1 and 3 are vertical angles, 2 and 4 are vertical angles?
Yeah.
Give me a thumbs up if your group said something along those lines. Yeah? Okay, what else did we come up with? Any other reason? Yeah, Liana.
2 and 3 are both supplementary, and 1 and 4 are supplementary.
2 and 3 are supplementary.
Well, I'm sorry. No. They're all right angles, I guess.
They're all right angles. All look like right angles.
All are right angles.
You have a protractor around? No, then we don't know they're right angles.
Prove it.
Oh, well, technically, yeah, why do we know they're right angles? My bad, I'm
I
tripping.
said so.
Okay, that's not what I was looking for. But, all right. Any other things? Anyone else want to add? Okay, let's go through this. I'll get it later. Now, technically, there's a couple different ways that we could do this. All right? And when we go through this, again, this is what I thought when I was a student. I was like, how are you just coming up with that? Right? Well, we kind of have to use sequence thinking. So we really have to break it down into the smallest little statements. The first thing we need to do is write the information that we're given. We are given that angle 1 is congruent to angle 2. The reason? Because it's given. I don't need a reason for my given information because it's been given to me. Now, I love what you guys came up with the vertical angles because they absolutely are vertical angles. Is there anything on the previous pages that talk about vertical angles? Is there anything, because what we're going to be doing with these proofs is you're going to be looking at these 2 pages that we just spent 30 minutes talking about, and you're finding things that are relevant to what this proof is asking for. So if we're going for the vertical angle, yeah, Gurpreet, what does it look like we might be able to use?
Wait, like the statement?
Yeah.
Wait, the vertical angles.
Hey, look at that. The vertical angles theorem says that if 2 angles are vertical angles, then they are congruent. Right? How do we know that 1 and 3 are vertical angles? What do you say? They're across from each other? Yeah? Tyler? They are congruent? Well, there's plenty of angles that are congruent that aren't vertical angles. Right? How do I know these are vertical angles? Tyler?
If you use like the given and the proof,
No, you're only supposed to use the given.
So look at the diagram, right, Changzi?
they're reflected from each other.
They're reflected from each other? Yeah, absolutely. I mean, the simplest way to describe it is there's 2 lines making an X, right? That's what makes vertical angles. 2 lines that intersect at one point produce 2 sets of vertical angles every single time. Doesn't matter if they're really, really skinny or really, really big. It doesn't matter. Every time we have 2 angles or 2 lines crossing, which these arrows tell me these are lines, right? Not line segments. We get vertical angles. So we can say, because the vertical angle theorem, angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4, thanks to the vertical angle theorem. It's like when you're writing an essay, you got evidence and you got analysis. Right? My analysis is the statements. It's what I'm saying is true to get me to my ultimate end goal of proving what it's asking me to prove. The evidence, right? The quotes that I pull from the book, the website that I have in my works cited page, that's what the reasons are over here. Okay? All right, So we know that angle 1 and angle 3 are now congruent. We know that angle 2 and angle 4 are congruent. What do you think might be our next little step here? It's kind of hard to just think about what's next, right? Liana, do you have an idea?
3 equals 4.
3 equals 4? What makes you say 3 equals 4?
Because 1 equals 3 and 2 equals 4 and 1 equals 2.
1 equals 3,
Yeah.
2 equals 4,
Yeah.
and 1 equals 2.
Yeah.
Good. We got to break it down a little bit because you took 2 big steps there, but you're absolutely on the right track. That's what we're going to now deduce, okay? What's the first part of that going to be? Tyler?
What do you say again?
The first part of deducing what Liana said, what were you going to say when you put your hand up?
Oh, I was just gonna do the same, kind of like the same example a little bit.
Okay.
It's like if 1 is equal to 3, and 1 is equal to 2.
Yep.
And 2 is equal to 4.
Ooh, you jumped a little bit too much. Let's take it step by step.
And 2 is equal to
If 1 is equal to 2 and 1 is equal to 3, then angle 2 is equal to what? Angle 3.
3.
What is that called? Transitive property. Everybody see how we made that leap? Yeah? Well, hey, I also know that 2 is congruent to 4. So if 2 is congruent to 4 and 2 is congruent to 3, 3, angle 3 is congruent to angle 4. Once again by the transitive property. What were we being asked to prove again?
If angle 3 is congruent to angle 4.
Did we prove that angle 3 is congruent to angle 4?
Yes.
Yes, we did. So this is like the bare minimum, simplest intro to proofs proof as we could do. Truly. You guys figured it out on your own, which I'm very impressed with.
It's like telling a robot the difference between 3 and
You said it's like telling a riddle?
a robot.
Oh, telling a robot?
What the difference between a 3 and
A 3 and a P?
you have to kind of like
It's kind of like it's like coding in a sense that we really have to break it down
you have to
into.
like say like
Bro.
what
What are you doing?
You guys okay over there, Aaron? Yeah? We're doing too much or what's going on? I don't know. And we don't need step 5. Hooray. There was one step in there that I took out because it's kind of stupid. It was the symmetrical property. Yes, symmetric. I don't like that one because it doesn't matter. Any questions about that? Quick show of thumbs. How does that sound to you? Thumbs up. That sounds great. Super fun. I love it. Thumbs down. Awful. Worst thing I've ever learned.
Don't we have to learn like 80?
Okay. We are...